we are going to discuss another way to determine whether a series is convergent or divergent, and it is by using a direct comparison test and limit comparison test. Comparison test. Suppose that we have two series AN and BN, with AN, BN greater than or equal to 0 for all n, and AN is less than or equal to BN for all n. Then, if the series BN is convergent, then so is the series AN. If the series AN is divergent, then so is the series BN. Let's have this example. Determine if the series 1 over 5 plus 2 raised to n is convergent or divergent. Now, in the comparison test, we are going to compare this series to another series, but we are going to remove a certain number that is not significant in the series. Let's concentrate on this given fraction. In this fraction, 5 is not significant, meaning yung value ng 5 is hindi naman nagbibigay masyado ng value or ng added value to the entire value of the fraction. Okay? And so, we will, by comparison test, we are going to compare this given fraction, which is taken from the given, and compare it with this fraction 1 over 2 raised to n without the insignificant 5. Okay, so we will compare these two. Now, we know that this one is less than 1 over 2 raised to n because we know that as the value of the denominator is greater than to the numerator, we know that the entire fraction mas nalilesen ang value niya. Again, we know that if the denominator is greater than the numerator, mas nalilesen yung value niya. Or as the denominator increases, the more the entire fraction, okay, as the denominator increases and yet the denominator is greater than the numerator, the more na nalilesen ang value ng entire fraction. Just like this one, 1/2 and 1/3. So 1/3, in 1/3, 3 is higher, 3 is greater than 1, and 3 is greater than 2. So if we're going to compare 1/3 and 1/2, 1/3 is less than 1/2. That is why here, since in this fraction there is an additional 5 in the denominator, but here there is none, that is why 1 over 5 plus 2 raised to n is less than 1 over 2 raised to n. Now, since we already know, and so this is also equivalent to the series, that the series of 1 over 5 plus 2 raised to n is less than or equal to the series of, actually it's less than to the series of 1/2 raised to n. These two are just equivalent. We can also write 1 over 2 raised to n as 1/2 raised to n. They are equivalent. Now, based in the comparison test, based in the definition, of the comparison test, an is less than to bn. An is less than or equal to bn. That is why this is our an and this is our bn. Okay? And now, take a look at bn. Take a look at bn. Our bn is a geometric series. 1/2 raised to n. This is a geometric series. Okay? Now, we know from our previous video that a geometric series in which our r here, we have previously know that 1/2 raised to n, its ratio is 1/2. Its ratio is 1/2. And since the ratio is less than or equal to 1, 1/2 is less than or equal to 1, therefore, this given series converges. The series 1/2 raised to n is convergent. Therefore, Bn is convergent. Okay? And then, based from the comparison test, based on the definition of a comparison test, based on the given condition in the comparison test, if the series Bn is convergent, and so is the series An. Again, we have proven that Bn is convergent. Okay, we have proven that Bn is convergent. Therefore, because of the condition given in the comparison test, An is also convergent. Therefore, since this is our An, therefore, the series 1/5 plus 2 raised to n is convergent. Here is another example. Determine if the series is convergent or divergent. The series is n plus 5 over n squared. So, we will focus on this given. So, on this given, 5 here is not significant. Kasi nga, ang value ng 5 in this given is hindi siya masyadong magbibigay ng added value to the entirety of the fraction. Okay? And so, we are going to compare these two fractions in which yung isa is the original given and yung isa naman is without this insignificant value, which is ang 5. Okay? And then, we know that n plus 5 is all over n squared is greater than or equal to n over n squared. We know for a fact na kapag ang numerator is, let's say we have, this is an example of a similar fraction. Similar fraction because they have the same denominator. Now, if yung numerator is greater than as compared to the other numerator, to the other fraction, to the numerator of the other fraction. So ang ibig sabihin nun, this one is greater than or equal to this one. Okay? Now, that is also equivalent to the series. Okay, so the series of n plus 5 over n squared is greater than or equal to the series of 1 over n. And based in the comparison test, based sa comparison test, that an is less than bn, okay? Or bn is greater than an. The series bn is greater than an. That is why this is our Bn, because this is greater than as compared to this one, to this series. So this is our An. Okay? Again, this is our Bn because according nga sa comparison test, Bn should be greater than or equal to An. Kaya nga, ito ang Bn natin at ito naman ang ating An. Now, it's either you want to prove that Bn is convergent or divergent, it will be up to you. Okay? But, since from the previous video, we have proven that the series 1 over n diverges, meaning divergent siya. Itong series 1 over n, na-prove na natin to from the previous video that it is a divergent series. Therefore, based on the condition given in the comparison test, that if the series an is divergent, therefore, ang series Bn is also divergent. So, the series n plus 5 over n squared is divergent. Here is another way to determine if the series is divergent or convergent using limit comparison test. Suppose that we have two series. We have the series An and the series Bn, with An greater than or equal to 0 and Bn greater than 0 for all n. Now, An can be equal to 0 because An is in numerator. Okay, so we are it's allowed to have a 0 value for An. And then for Bn, we have to have greater than 0 value. Kasi nga, andito siya sa denominator. Okay? And so, we define that limit of An over Bn as n approaches to infinity equal to L if L is positive and finite, then either both series converges or diverges. Here is an example. Determine if the series is convergent or divergent given the series 1 over 5 plus 2 raised to n. Okay, we know the given series 1 over 5 plus 2 raised to n to be our An, and the series 1 over 2 raised to n to be our B raised to n. Again, so this is our Bn. This is from we got it from here, but we just removed the insignificant number 5. Now, in the given limit comparison test, there's no condition whether An or Bn is greater than or equal to the other series. Okay, we do not have conditions that An should be greater than Bn or Bn should be greater than An. But since An is, of course, the first series, so we assume that An is the given series. Okay, and then the Bn is the other series without the insignificant number. Therefore, we get the limit of An times 1 over B raised to n. Now, this one, instead of writing it as An over Bn, okay, the limit of An over Bn, sineparate ko ang An at saka yung 1 over Bn. Para lang mas klaro sa ating, if we're going to evaluate it already. Okay? And then, we have this one. We're going to substitute An. So, An is 1 over 5 plus 2 raised to n. And our 1 over Bn is 2 raised to n. 1 over Bn, that is 1 over 2 raised to n. This is our Bn. And if we're going to simplify 1 over 1 over 2 raised to n, it will be equal to 2 raised to n. Okay, and then let us simplify this one. So that is equivalent to, this one is equivalent to 2 raised to n over 5 plus 2 raised to n. And then, to get the limits now, we know that as n approaches to positive infinity, the limit of this entire given fraction is equal to 1. Okay? Again, as n approaches to positive infinity, meaning as n increases in this given quantity or fraction in particular, the entire value of the fraction is, kumbaga yung value ng entire fraction as n approaches to positive infinity is nag-a-approach din to the value 1. That is why our limit is 1. Now, since the limit is 1, which is finite, therefore, the two series, which is the an and bn, are convergent. Another example is, let us determine if the given series n plus 5 over n squared is convergent or divergent. Again, so this is our an and this is our bn. Okay, they look similar, but without the series bn is without the insignificant number 5. Okay, and then we will get the limit. So the limit of an times 1 over bn. So this is our bn. So for 1 over bn, that will be equal to 1 over n squared. Okay, and then to simplify it, that will be equal to this one. Okay, yan ang equivalent niya when we simplify this one. And then, this one is equal to this one because we already cancel n squared. And so we have the limit of n plus 5 all over n as n approaches to positive infinity. Now, as n approaches to positive infinity, the entire value of the fraction is also approaching to positive infinity. Okay, again, as n approaches to positive infinity here, okay, so yung entire value ng fractions ay nag-a-approach din sa positive infinity. Okay, there's no certain value kung saan nag-a-approach yung value ng fractions as n approaches to positive infinity. Continuous lang lagi. Continuous lang. Let's say, when n is 100, so that's 105. So let's say n is 100, so this is equivalent to 105 over 100. And then, if n is 1,000, so this is 1,005 over 1,000. Okay, so as n increases, yung value naman ng fractions ay nag-i-increase din. Hindi nag-a-approach to a certain value. That is why the limit is positive infinity. Since the limit is not finite, therefore the two series, the an and bn, are divergent. So again, using the limit comparison test, example 1 was proven to have, the two series was proven to be convergent. Okay, the AN and BN are convergent. And for example number 2, because using the limit comparison test, the two series, which is the AN and BN, were proven to be divergent.